two students to the homework up video page. 294, numbers 5 through 33. This mimeopad is not working, so give me 1 second here, guys, to get this thing working. And there we go. I did not have it turned on, but it is turned on now. Okay, page 294, numbers 5 through 33. Here we go. Okay, numbers 5 through 11. The directions say to find the domain and range of the function. Now, let's take a look at these real quick. Number 5. Okay, now, domain. Domain, of course, is, well, let's draw this down here. Domain deals with what x is doing, what the graph is doing in relationship to x. So we're looking at how the graph moves this way and this way. Well, it's never going to stop. As it goes up continually, it'll get further and further to the right. And as it goes down, it'll go further and further to the left. Do you see that? Never stopping, going further down, but going to the left. So the domain is simply all real numbers. Alright, now let's take a look at the range. Now remember, the range deals with the graph. The graph in relationship to the y values. So notice the graph will continue to go. Of course, y values is the going up and the going down of the graph. Well, it's going to continue to go up, and up forever, and down, and down forever. So I'm going to use ditto marks. All real numbers would be the answer. Okay? Alright, moving on to number 7. Now, let's take a look at this. Let's start with the domain, okay? The domain. The domain is the x, is the graph. The x values in relationship to the graph, okay? So, we're going to look at what the graph does going this way and this way. Now, this one can be confusing, but I don't care how gradual the movement to the left is. It's going to be really gradual and slow, but it's the further up this parabola goes. Even though it's going to be really slow, it will always continue going to the left. This parabola will never come up and eventually flat. It'll never flatten out and go straight. It's always going to be gradually going to the left. It's always going to be gradually going to the right. So the domain for this graph is all real numbers. Now the range is the y values in relationship to the graph, okay? So here we go. The y values deal with the graph going down and up. Now obviously it's going to continue going up and up and up forever. We can all see that, can we not, guys? Arrows going up, up. But it's not going to go down forever and ever. In fact, it stops right here. Now we're allowed to just kind of estimate using the graph. Notice these tick marks here are in increments of 2, 2, 4, 6. So this is right in the middle, so we're at about 1 on the y-axis. Do you see that? We're at about 1 on the y-axis. So, the graph is above 1. It's above 1. So students, the range is going to be all, well, I'm going to go ahead and just use ditto marks, all real numbers greater than 1, okay? Now, in the book, I just want to warn you, in the book, they want you to actually find the vertex of this, and then once you find the vertex, I think the vertex of this was 0, 7, 8. So you went over 0 and up 7, 8, so it's really not quite to 1, okay? But I'm not going to make you guys be that in depth. So just using the naked eye and estimating, I have no problem with that. So the range is all real numbers greater than 1. Now actually you can say greater than or equal to 1 because it actually is 1 is part of the vertex. So I would say all real numbers greater than or equal to 1. Okay, moving on to number 9. Okay, now let's start off with obviously the domain first of all. The domain deals with the x values in relationship to the graph. So we're looking at the left and the right behavior of the graph. Now obviously, it's going to continue on and on to the right. But it's not going to go past this point here, okay? Now we're going to estimate and say that's 3. So the x values of this graph, and notice on the last problem, when we're dealing with range, we use the y values on the y-axis. That's because we're dealing with range. Remember, range is interchangeable with your output or your y values. Here we're dealing with domain. Domain is interchangeable with your x values or your input. So we look at the x-axis. So your domain is all real numbers greater than or equal to 3. All real numbers greater than or equal to 3. Now, let's take a look at the up-down behavior or the vertical behavior of the graph. Obviously, as it continues going to the right, it's never going to completely flatten out. I don't care how gradual it is. As you go to the right, it's always going to gradually go up. I don't care if you go out to 1 million on the x-axis, it's still going to gradually continue to go up, okay? So, we know it's going to continue up. However, it's not going to continue down. It stops right here. Now, remember, we're dealing with range. So you have to look at the what axis? The y-axis. If you look at the x-axis, you're going to think the range deals with 3. That was domain. Range deals with the y-axis. So this point right here is even with where on the y-axis? 0. And notice the graph goes above 0. It goes up, up, up above 0. So your range is going to be all real numbers greater than or equal to 0. That's going to be your range. Alright, moving on to number 11. Now this one's going to be a lot more interesting. So here we go. Now your domain, first of all, is the left and the right behavior of the graph. Well, obviously, it's going to continue going left forever and ever, but hold it. It comes down, and as you can see, it's getting closer and closer. Now, first of all, the tick marks are in increments of 2. And I'm not sure why they gave this to you. This is a problem here that really we get a little more into pre-cal and also in Algebra 2, but it would be in the rational functions, which I'm looking right now in the book. I think that's around chapter 12. Maybe chapter 11, 12, 13, but anyways, that's fine. We'll go ahead and address this. And I also gave you one of these as an example in your notes too, so we'll see how it goes here. Okay, now, as you can see, it's going down, and just so you know, it's going to gradually get closer and closer to 1, negative 1, but never cross it. Now, I don't expect you to know that. We learn this later. I'm not sure why they're giving this to you now. Later on, you're going to learn when you have a fractional function like this with x in the denominator, you take the denominator and you set it equal to 0 and you solve, okay? And you get negative 1, and that tells you there's an imaginary dotted line there that you can't see that the graph will never cross. Okay, now again, I'm not going to quiz you or test you on these, but still we'll go over this, okay? So, the domain is all real numbers less than negative 1, okay? And then it's also all real numbers greater than negative 1. So in other words, the best way to say this is your domain's going to be all real numbers except negative 1. That's going to be your domain. Okay? That's a tough one, I know. I'm not going to quiz you or test you on that. We'll be looking at problems like this way in the future toward the end of the year this year, okay? Alright, now. But it's still good for you to see these. The range. Okay, the range is going to be, there's an imaginary dotted line right here on the x-axis, okay? Now, I know that because the power of the x up here, even though you can't see it, is 0. You're going to learn all this later, okay? I'm not going to test you on this or quiz you on this, but just listen to me. Up top here we have a power of 0 for your x. Here it's a power of 1. Anytime the power in your denominator is greater than the power in the denominator, you have a horizontal asymptote or a boundary at 0. So this graph is going to be all real numbers less than 0, and all real numbers greater than 0. So we're going to say all real numbers except 0. Okay? Now just take notes on that. I'm not going to give you one that hard on a test or a quiz, but it's still good for you to see that, okay? Alright, numbers 13 through 19. We're going to add these two functions. We're going to either add, subtract, multiply, or divide these two functions together, okay? So here we go. The two functions are f of x equals, I'm going to copy this down, and then I'll cut and paste it. F of x equals x plus 1, and g of x equals 2x. Okay, number 13 says we're going to take our f function right here plus our g function. So we take our f function, x plus 1 right here, plus our g function, which is this right here. So we have, there's a positive sign right here. So drop the parentheses, none of these change. There's a positive sign here, so drop the parentheses, and your sign doesn't change. X plus 1 plus 2x, there's a 1 right here. X plus 2x is 3x plus 1, and we're calling that h of x. So h of x equals 3x plus 1. We simply added those two functions together. Number 15, let's go back and copy these real quick so we have those. Okay, we're going to take 2 times my f function and then minus my g function. So 2 times my f function. So 2 times, here's my f function, then minus my g function. Alright, let's take this step by step. First of all, you have a 2 here. You're going to distribute through the parentheses. 2 times x is 2x. 2 times positive 1 is positive 2. Then you have a negative sign here. Well, a negative times a positive is negative 2x. Okay? So your x's cancel. 2x minus 2x is 0. You're left with 2. So h of x equals 2. H of x equals 2. Alright? Number 17. Okay, in order for us to get h of x right here, I'm going to go ahead and put h of x. H of x equals my f function, which is x plus 1, times my g function. And here's my g function. Now be very careful. Here's what a lot of you want to do. You want to take this 2 and multiply it through, and then take your x and multiply it through. And you're probably saying, Mr. Earhart, you taught us to do that. Well, no, I did, but I didn't. I taught you to do that when there's 2 terms like this. If it was 2 plus x, then you would take your x, multiply it through, take your 1 and multiply it through. But it's not 2 plus x, it's just 2x. That's one term. Remember, positives and negatives divide an expression up into terms. So because I have a positive sign here, I have 2 terms. Here's one term, here's the other. I do not have a positive or a negative here. They're multiplying. So because they're multiplying, that's one term. So I'm going to take 2x and multiply it through. 2x times x, 2x squared, 2x times 1, 2x. So h of x equals 2x squared plus 2x. Alright, 2x squared plus 2x. Alright, moving on to number x, that's 2x, divided by, so I'll put a fraction bar, f of x, x plus 1. And to be honest with you students, that's your final answer. Okay? And here's why. A lot of you want to cross off an x here and cross off an x here and be left with 2 over 1. You cannot do that because here's why. We have two terms in the denominator. We have one term up here, two terms down here. Anytime you reduce a fraction, you have to reduce it to every term. So let's pretend that we had an x here also. Then you could cross off an x from every term. That would be totally fine. Okay? Or if we had, some students would see like a 2 here and want to cross off the 2's and be left with x over x plus 1. Okay? And that's not right. Now if you have a 2 here and a 10 here, then you could cross off the 2, make it a 1, cross off the 2, make it a 1, cross off the 10, make it a 5, and reduce everything by 2. That would be totally acceptable. However, we don't have that, so that's as far as you can go right there. 2x over x plus 1. Alright, moving on to number 21 through 25. We're going to do composition of functions. Composition of functions. So here we go. We're going to do f of g of x and then g of f of x for each one. So here we go, number 21. We're going to do f of g of x first. So notice my first function is f. So I bring the f function down, and everywhere there's an x, I'm going to put a big parentheses. So I put a big parentheses for x, and then plus 1. And then g of x comes next. So I pick up my g function and put it in the parentheses here. Let's go over that again. My first letter on the outside is f, so I take my f function, x plus 1, and I write it right here. I wrote it right here, but where the x was, I put a big parentheses because I know I'm going to make a substitution. And then the next letter I see is g. That means I'm going to pick up my g function and put it right here in the parentheses. And that's what I did. Now 2x plus 1 is 2x plus 1. So that's your answer. Alright? Okay, moving on. Okay, now students, we're going to find g of f of x, okay? So g of f of x. Here we go. Okay? We start off with our g function, okay? So here's our g function right here. G. G's on the outside. So here's your g function, 2. Then parentheses for the x, okay? So our first letter is g. Go to your g function. Write it down here. Everywhere there's an x, we're going to put a big parentheses. Now your next letter is f. So go to your f function. Pick it up and put it in the parentheses down here. And now we're done. Take your 2 and multiply it through. 2 times 2x is 2x. 2 times 1 is positive 2. So g of f of x equals this. Okay? Composition of functions. Number 23. Alright, let's first of all find f of g of x. Okay? F of g of x equals, okay, what is your first letter? F. So take your f function. Everywhere there's an x, put a big parentheses. Now your next letter is g, so pick up your g function and put it in the parentheses. So there we go. X minus 1 squared. X minus 1 squared means x minus 1 written twice. Now take your x, multiply it through. Then take your negative 1 and multiply it through. X times x is x squared. X times negative 1 is negative 1x. Now take your negative 1 and multiply it through. Negative 1 times x, negative 1x. Negative 1 times negative 1, positive 1. Now, combine your like terms, negative 1x, negative 1x. You owe me $1. You owe me a negative $1. That's negative 2. And then bring this down right here. So f of g of x. F of g of x equals x squared minus 2x plus 1. Alright, okay, moving on. Okay, now students, we're going to take a look at the other direction of our composition, g of f of x, okay? G of f of x. Okay, now notice your first letter is g, so you go to your g function, and where the x is, you put a big parentheses. Okay, there we go. Now next is your f function, so you pick up your f function and you put it in the parentheses. There we go. So we're left with g of f of x equals x squared minus 1. Alright, x squared minus 1. Moving on to number 24. We're going to start off by finding f of g of x. F of g of x equals, now, what letter came to the left here first? F. So pick up your f function. Everywhere there's an x, put a parentheses. Now the next letter is g. So pick up your g function and put it right here. And so our final answer would be f of g of x equals x positive 3 minus 3, which of course positive 3 and negative 3 is 0, so you just have x plus 0 or just x. Okay, so f of g of x equals x. Now let's solve for g of f of x. G of f of x. Look at the first letter is g, so go to your g function. Everywhere there's an x, put a big parentheses. So parentheses for x and then positive 3. Now the next letter is f, so pick up your f function and put it in the parentheses. Well, here we go. We have x negative 3 positive 3. Your 3's would cancel, leaving you with x. Okay? So now we have g of f of x equals x. Okay? So there we go. There's your composition. Alright? Alright, moving on. Alright guys, let's take a look at numbers 27. Here we go. Alright, now, the directions for 27 say to write an equation for f of x. So, here we go. Or for h of x. H of x equals 2 times f of x, okay? So, h of x equals 2 times f. Here's the f function right here, okay? 2x minus 8. Okay? So 2 times the f function. So take your 2 and multiply it through. H of x equals 4x minus 16. Alright? 4x minus 16. Alright, moving on. Alright, moving on to number 29 now. Okay, so our h of x function, we're going to take our g function, which is right here, g function, x squared, minus our f function. Be sure and put your f function in parentheses, because you're subtracting the entire function, not just 2x, okay? And really, technically, I should put this in parentheses also, okay? So it's x squared minus 2x minus 8. Now, if these two parentheses were side by side, like this, then obviously we'd be multiplying. We would take the x squared and we'd multiply it through, okay? But that's not the case. So we have a positive in front of this parentheses here. Positive times a positive is positive. Now we have a negative outside of this parentheses. So take the negative and multiply it through. Negative times a positive is negative. Negative times a negative is positive. Notice there are no like terms. There's only one x squared term. There's only one x term. And there's only one constant term. So there is no simplifying we can do. There are no like terms that we can combine. So that's as far as we can go. Number 31. Okay, now we're going to say h of x equals f of x, which is 2x minus 8, divided by g of x, which is x squared. Now remember what I taught you. A lot of students want to cross off one x here, cross off one x here, so you're left with an x here, and put 2 minus 8 over x, which is negative 6 over x. And that is totally incorrect. You cannot reduce fractions unless whatever you reduce by goes into every term. Notice down here I have one term, up here I have two terms, okay? So, if there was an x here, then I could reduce everything by x. If there was a 2 here, then I could reduce everything by 2, okay? But there's not. So, that's as far as you can take this. This is your answer. 2x minus 8 all over x. Okay, that's as far all over x squared. That's as far as you can take that. Alright, number 33. We're going to do composition f of g of x. So, notice f is on the outside, so we pick up our f function and we write it first. Everywhere there's an x, we put a really big parentheses. 2x minus 8, so put a parentheses for x. The next letter's g, so pick this up and put it in the parentheses. So we have 2 times x squared minus 8. 2 times x squared is 2x squared negative 8. And that is your answer. H of x equals 2x squared minus 8. Okay. Guys, I hope this homework video has been a help to you. If you have any questions, don't hesitate to call or email.